By now I think you understand the concept about break and continue. So we already look at the example test break and test continue, and you also have the question in the learning chat. Now let's look at the other kind of example. We can use break as a post-test loop. What does it mean by post-test loop? So I have this code. In other programming language, for example, C, or the other programming language like Java, they have do while. It means the condition will be at the end. So whenever you do the loop, you always see that the condition is in the first part. Now, if we have the condition after we do something, how we can define the condition? So we call this is the post test. So we need to run the program first. We need to run the statement first, and then let the condition will be at the end. So in that case, if you are doing with C, you will use this code. I equals to 1, and then you will do this statement, you will print, and then you will add by 1. Now, if you use Python, you will do like this one. So let me practice. If you use Python, I can define I equals to 1, and then while true. What is the meaning by true? This is Boolean. So when it is true, we will always do this statement. The question is, when will it become false? It will be never false, but we have the condition with break statement. It means that if the condition satisfied, we will stop this iteration. So you can see here, while true, then I equals to 1, it will be printed, and then I equals to I plus 1. So we need to check what is I, because I is 1 at the first time, and then after we add by 1, now it becomes 2 for I. 2 is greater than 3? No. So we will check, is it true? Yes, this is true. So we will print I. What is I? I is 2. So we will print 2. And then 2 plus 1. So it becomes 3. 3 is greater than 3? No. Then we will go back again. Is it true? Yes. Then we will print I, which is 3. 3 will be added by 1. Then it becomes 4. And then check. 4 is greater than 3? Yes. Then print. It means we will stop print. If you run this, we will get the value 1, 2, 3, and then stop. So the condition in this while, it can be replaced with 2. Now let's look at the example about prime numbers. I don't know the Korean prime numbers. So this numbers is we need to write a program that display the first 50 prime numbers in 5 lines, each of which contain 10 numbers. So we need to print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we go to the next line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we go to the next line. So we will print every 10 numbers, and those 10 numbers should be the prime numbers. The prime numbers means it is an integer greater than 1 if its only positive divisor is 1 or itself. Okay. The definition is 2, 3, 5, 7 are prime numbers. 4, 6, 8, 9 are not. Because we can only divide 2 with 1 and 2. We can only divide 1 and 3 with 1 and 3. We can divide 5 with 1 and 5. We can divide 7 with 1 and 7, and so on. We can divide only with 1 or itself. 1 or itself. So the solution, the problem can be broken into the following tasks. So for any numbers, we can have 2, 3, 4, 5, 6, and test whether the number is prime. And then determine whether a given number is prime or not. And then count how many of the prime numbers. After you find it, then print its prime number and print 10 numbers per line. I give the solution prime numbers. There is the code prime numbers. So I would like to have the 50 numbers. And then for every line, there will be 10 numbers. Let the count is the number of prime numbers that start with 0. And then the number start with 1. So I would like to check from 2. Okay, so I do not want to start from 1 because 1 divided by 1 is 1. And itself is 1. So we cannot count 1 as a prime number. So we will start with 2. So the first 50 prime numbers are, let's do the checking. If the count is less than number of primes, so we are going to check 50 numbers. So if the count is not 50, okay, let's have one variable, whether it is a prime number or not. So I would like to put is prime equals to 2. Divisor. So the divisor equals to 2. So I would like to check if the divisor is less than or equal to the number divided by 2. So if we have this condition is true, we will check this. What we are going to check if it is true, then the number is not prime. So we put the is prime is false and then print. So this will be only for checking whether the number is prime or not. After we know that this number is prime or not, then we know if it is prime. So if it is true, we will do additional count plus 1. And then the formatting, we just want to print and then give some space, 5 space. After we give 5 space, and then we check. If there are already 10 numbers, let's go to the next one. Okay. And the number will be added by 1. So if the number start by 2, the number will be added by 1. It means we go to the next, which is 3, and so on. If you run this, so we get the first 50 prime numbers. 2, 3, 5, 7, 11, 13, and so on. So we have 10 numbers per line. And then we have another 10 numbers. We have another 10 numbers, and so on. Okay, so this is about the prime numbers. Now, we have another solution, another problem. Cumulative sum. Keep looping the input positive integer number until 10 times and do the summation of all numbers. I think I don't put any. Do I put this one, cum sum? No, I don't put the cum sum, okay? So it means you need to write by yourself. Okay, let's try to do together how we can solve this problem. Cum sum. So if I give you like this problem, keep looping the input positive integer number until 10 times. So I will do the input for 10 times. Then I can say count equals to 0. Okay. While count is less than 10, because I want to do 10 times. If count is less than 10, okay, before I forgot, I will do the count plus equal to 1 at the end to avoid the infinite loop. And then I need to input positive integer numbers. So I can input any number. Let's say num. It will be the integer of input a number. The question is, do the summation of all numbers. So we will do the summation. You can do like total, for example. I will start total by 0. Then, because I will do the summation, then total will be equal to total plus number. So let's assume that this is positive integer number. Okay. Is it done? Let's try. Input a positive number. Okay, let me just 1, and then okay, next is 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So I can do the summation. Oh, sorry, I can do the loopings, but I still do not print the total. Okay, so I can just put another print the total. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, the total is 55. Okay. If you want to make it more better representation, total is total. Okay. If I have questions, can I input negative? Yes, of course, we can input negative. So how if I want to limit the input? So only positive number can be. So I need to have 1. It can be 1 in another one. While num is less than 0. So if the number that you input is negative, do again. Okay. So in this case, I can do something like to make a confirmation. I put the count. So I know what is the count number now. Okay, let's see. Is it correct? Oh, yeah, I cannot do like this one because it should be 3. Yes. Oh, okay, I need to input the string. Input. This one is always, I need to put into one string. Okay, let me just use this one. So if we have the -1, so it will be counted, it will not be counted. Okay. So you can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So every time it is negative, it will not be counted because we have another while to limit the negative number. Okay. So this is about the cumulative sum. And if you need to have only the positive integer number. Now, there is another condition, there is another problem. We want to make a cumulative sum with sentinel value. So what is sentinel value? So keep looping the input positive integer number until the number is negative. So now we have another problem. If it is negative, we stop. Okay, so we do not need to do the loop until 10. But if the input, let's say 3, and then 4, and then 2, and then 1, and then minus 5. So if the input is negative, stop the loop and then show the summary. Okay. I think I give the example cumulative sum with sentinel value. Oh, I don't give the solution. Ooh, okay. Then that's right. How can we do this? Then we don't need this one, because when it is negative, we need to stop. Then the condition will be, yeah, it depends on you, what you want to define the condition. Let me have, this is true. Okay. When it is true, so I will do the loop, input a number, positive integer, okay. And then before I do something for this additional, I would like to check if the number is less than 0. Okay. So if it's less than 0, then let's break. Go. Yes, then it means we will stop the loop whenever it is negative. Can do. Input positive number 5, 3, 2, minus 1. Okay, stop. Okay. So this is the meaning by the sentinel value. The sentinel value is any value that you can give to stop maybe the loop or stop the operation. Okay, there's another interesting study in the book. Actually, it is too advanced, but let's see. If you learn about statistics, there is the statistics about random walk. So we want to apply it into the turtle. I think you know when we are in the first lecture, we learn about a turtle. So write a turtle program that simulates a random walk in a lattice. In a lattice means, yeah, we have this kind of maybe, yeah, we call it garden. And then let's look at the how we can look at this garden by walking through the garden randomly. So it can start from the centers and ends at the point on the boundary. So it can be in any point. So let's see. There's one example, random walk. There's one example, random walk. So yeah, you can look at this one. Okay. So it is based on the random number. and the random number, yeah, because it is random. At first, you will make a kind of garden. It is 16 by 16 lattice. After you have the garden, then let's try to make the turtle walk randomly. That means it can random in any position. We can random forward, or yeah, we can random in any direction, walking to east, walking to south, walking to the west, walking to the north. So with this simple idea, uh, it creates this kind of garden, and then the turtle will walk randomly. If you run again, then the turtle will have another kind of walk randomly, because the lattice should be made at the first time. Then yeah, it is made for the first time. So yeah, now it is a random walk, another random walk. Okay. Yeah, you can look at the code, but yeah, this is just for your game. Okay, there will be no question about the turtle in the quiz. Don't worry. In the industrial engineering, you will learn later about the simulation. There will be one subject about simulation. And in the simulation, we have one method. We call it the Monte Carlo simulation. The Monte Carlo simulation, it refers to a technique that uses random number and probability to solve the problem. So this method has a wide range of application in the computational mathematics, physics, chemistry, and finance. So there are many applications for the Monte Carlo, but for this example, I would like to give you one simulation how we can estimate the pi. You know pi? Pi is the constant of the how we can calculate the circle. Pi. How we can get 3.14 something something something. The idea of pi is from the simulation. So I give you the code. Maybe for you it will be very tough to understand this one, but let's see how the Monte Carlo, yeah, here there's the Monte Carlo simulation. This is the simple code to do the simulation. So there are some trials. So we need to define the number of trials and the number of hits. And for every numbers, yeah, we will do the random number until the number of trials. So in this case, we have like 1 million. We have 1 million times to do the trial, and then we will do the random for x. We will do the random for y with this formula. After we do the random with this formula, we will check if this x power of 2 plus y power of 2 is less than or equal to 1. Let's do the number of bits by 1. Add by 1, add by 1, add by 1. And then after we end this loop, we can get the pi. The pi will be 4 multiplied by the number of bits divided by the number of times. So this is the simple Monte Carlo simulation. If you run this one, you will get the pi will be always nearby 3.14. So you can run again. It will have a different value, but it is always nearby 3.14. It is always nearby 3.14. It is always nearby 3.14. So we use this for loop to find a particular number. Okay, so this is the end of this section. You learn about the while statement, you learn about for loop statement, you learn about nested loop and break and continue statement. So the remaining are only some more problems. You can find the solution in the PyCharm. You can look at those. Okay. So yeah, I will stop. And for next